Even if you want, it would be a totally fair test taking strategy if you were here in class. If you were taking it and I was watching you, you could look at these and then as soon as I give you your quiz, you could write it down at the top. So that would be fair. So if you're at home taking a quiz, look at them right before, make sure you have them memorized. Then as soon as you start your quiz, you can write them back down. Okay, so just be honest in how you take your test. I believe it will be a no calculator as well. Yeah, for sure, no calculator. I don't have it written. I don't know if it'll be multiple choice or free response. What would be the difference between a multiple choice and free response in terms of how your answer would have to be?
Free response is not hard, or it's more harder to teach.
Is sure, you can't guess. Okay, on a free response, you can't guess. Also, on a free response, you do not have to simplify your answer. So, like, let's say on 2, if I asked you question 2, if it was a free response, it would be perfectly okay to leave your answer right here. This answer would be acceptable. No simplifying is necessary on a free response. On a multiple choice, the only reason you would have to simplify is because you have to simplify until you make it match an answer, right? So there are pros and cons to free response and multiple choice. So while you might think free response is harder because you can't guess, in a way, free response is easier because you don't have to simplify. So I think that in the end, they both work out. Let's see, what else could be on your quiz? So you've got product rule, quotient rule. The other topic that's going to come up is motion. So make sure you've studied your 2-4 assignment, both A and B. Okay, so like this box right here, make sure you know position, velocity, and acceleration. Those are like the 3 topics that I'm going to put on your quiz. So motion questions and product and quotient rule. All right, so the questions that you guys had from last night's homework, 6, 9, and 15. I guess one other thing before I forget to mention what to expect tomorrow. So tomorrow, Friday, no, you don't come into class. I'll have a Google Meet from 9 to 11. So like if you want to stop in and ask questions, I'll have a link to it on Canvas. I haven't got it set up yet. I'll put some like maybe just brown VHS or something because it'll be open to all of my classes, not just AD, but all of my classes. I'll just leave it open as I work so you can stop in and ask me a quick question if you want. But for the most part, Fridays, you guys are working on your own. So tomorrow, I'm not even going to put together a video. After looking at it, I think we need some practice on limits. I'm going to keep the assignment really short. So you're going to have 2 things to get done tomorrow. You're going to have a quiz. The quiz, I always like to keep them short. It'll take you maybe 20 minutes. So you'll have like a 20-minute quiz to take. And then I'll give you about 30 minutes of work on reviewing limits. It's not going to be new material, so there's not even going to be a video you have to watch. I'll post the assignment and then I'll post the solution. So you should be able to get both of those done tomorrow. Okay. Any other questions? I think it's important to remember, not just in this class, but in all of your classes, the school board has approved this whole Friday schedule just through like Christmas break. Like we know we're going to keep it through December. And if we want it to continue, we have to make sure that we are showing that Fridays are like academic days. It's not just a 3-day weekend every time. You know, the whole purpose is you guys are still learning on those Fridays. And I don't know, maybe we want it to go back to in-person, but especially in this class with AP, like we have material we have to cover. So we will always cover something. But I think it does kind of work out nice that we can put the assessments on the Fridays. Okay, the first question you guys had was number 6. I can think of 2 ways to do this question. Any thoughts? Did I hear something? I can think of 2 different methods we could use. How did you guys, we're asked to find the derivative. Yeah, Sean. Yeah, I would distribute as well. You could use product rule, but if I can avoid product rule, I will always avoid product rule. So if I distribute and simplify first, then the derivative is pretty easy. If I distribute it, I've got 1 over t squared times t cubed and 1 over t squared times t squared. But we really could just write those as one fraction, like t cubed over t squared and t squared over t squared. What is t cubed over t squared? T. So that first fraction just reduces to t. T squared over t squared is what? 1. Have I taken a derivative yet? No. So make sure on this side that you're always labeling it. This is still f of x. Sometimes that's where we make mistakes. We just forget where we are in the problem. So this is f of x. Now we can take the derivative, or in this case, f of t, I guess. What is the derivative of that? 1. Just the slope of that line, the number in front of the variable. So the derivative was super easy. if we multiplied it together first. If you did product rule, you would have something equivalent to 1. It would just look terrible and you'd have to do a lot of simplifying. Okay, the next question is number 9. What are your guys' thoughts on 9? What are our 2 options? Similar to the last one.
Product.
Okay, you could do product rule. What else could we do? We could distribute. I'm going to choose to distribute. If I distribute, though, I'm going to rewrite this. How can I rewrite the square root of x? X to the 1/2. Very good. So if I rewrite that as x to the 1/2, and then I distribute, what's our rule? Go to something like, if I said x squared and I asked you to multiply it by something like that, what's our rule when you multiply x squared times x cubed? We add, right? So that's why we get x to the 5th. So whenever you forget the rules, just go to something that you know. So when we do this, we need to take the 1/2 plus 1. What's 1/2 plus 1? What was it? 3/2. I like improper fractions are going to be easier to work with, so I would write it as 3/2. And then I would do x to the 1/2 times 1. Well, that's just x to the 1/2. Yes, Milo.
That's a 3/2.
Okay, so again, elementary math is our hardest, right? If I'm doing 1/2 plus 1, I say this like not jokingly. I know it sounds funny, but it like I know that it's true, right? That 1 we can rewrite as 2/2. So when we add it together, we get 3/2.
We can go over that.
Yep. So it's okay. So we're asked to add 1/2 plus 1, right? Or do you agree with that? We're trying to figure out the 1/2 plus 1. In order to add fractions, you need a common denominator. So I need this 1 to have a denominator of 2. I need to multiply by 2 then. Whatever you do to the bottom, you have to do to the top.
Oh.
Well, 2/2 is equivalent to 1. So we're really doing 1/2 plus 2/2. That's why we get 3/2. So to make sure you still got that, and for everybody else, what if I said 5/2? Actually, let me say 5/7 plus 1. What would you do to add 5/7 plus 1?
You times by 7.
Good.
Divide it.
Yep, so you just write it as 7/7. Make sure it's equivalent to 1. 7/7 is the exact same value as 1. Now we can add them together. Denominator stays the same, and we get what? 12, so 12/7. Okay?
The
Good. Okay. It's worth clarifying, guys. I promise you, like I see more mistakes on that stuff than anything else. Okay, now we're ready to take the derivative. The power comes down. Oh, we get to practice fractions again, and we minus 1. What is 3/2 minus 1? 1/2.
1/2.
Because the 1 you can write as 2/2, so we get back to a half. This 1/2 comes down, and we minus 1. What's a half minus 1? Negative 1/2. I'd be totally fine if you leave your answer like this. Okay. The other question, you guys had just one more, but if you have others, I'm happy to take them. But 15 was written in there, added to the Padlet. Okay. 15 says, find the x coordinates of the points at which this graph has a tangent parallel to that line. This word stands out to me. What's true anytime lines are parallel? Same slope. Same slope. So I'm going to start with that. So I know I need the same slope. I need the slope of the tangent line. How do we find the slope of the tangent line? What do we call the slope of the tangent line? What is it? Derivative. Good, Lance. So the slope of a tangent line, that's just the derivative. That would give us the slope of the tangent. What is the slope of the line that they're giving us? What's the slope? 6, right? Notice, watch how cool this is. It is also the derivative of this. What is the derivative of that line? 6, right? So the slope of a tangent line is, you could just take the derivative of the line, but it's just the number. So we need those two things. If we want the same slope, we need them to equal each other. So we want g prime to equal 6. We need to take the derivative of this. I can think of 2 ways to take the derivative. What are our two options? Everybody agree? You guys are like me today. I'm like really no motivation. You guys seem like you're in the same boat. Okay, so we have two factors. So our two options are we can multiply them together or we can do product rule. What do you guys want to do? Product rule, sure. Let's practice product rule just because we haven't done it for a while. Product rule is going to come up. Okay, so I'm going to take g of x. If you want to multiply it together, do it the other way and then we can compare. But I'll show you product rule. Who has product rule memorized? Has the F and S. Good, so it's first times what?
Derivative of the second
Good,
plus the second times the derivative.
perfect. Doing all right with that? Okay, so if I apply this, g prime, the first, I just keep it in parentheses. S prime, I need the derivative of the second. So, Haley, what is the derivative of x squared plus 3? Great. And then I'm going to add the second and I'll leave it be. And then let's see, Cameron, what is the derivative of the first?
Just 2.
Good. If this was a free response and I just asked you for the derivative, it would be okay to leave this as your answer. This question's asking us to do a lot more, so we need to keep going. I'd simplify, so I'm going to distribute. That would give me 4x squared minus 2x. I'll distribute here. I get a 2x squared and a plus 6. We can combine like terms, so I've got 6x squared minus 2x plus 6. I need to label it. What did I just find? G prime, right? So this is still the derivative of g. Just need to make sure I'm always identifying where I am in the question. This problem, I'm trying to solve this. Where does g prime equal 6? So I'm going to take g prime, that equation that we have. I'm going to set it equal to 6. If you don't have a calculator, it's going to be pretty easy to solve by factoring. If you're going to solve by factoring, what's your first step? Move the 6 because we need it to be equal to 0. Okay, so solving by factoring only works if you set it to equal to 0 first. So if we minus the 6, we have 6x squared minus 2x. Once it's equal to 0, it should be pretty easy to factor. What do those two terms have in common? The 2x. And what do we have left? Bad? Okay, Hayden, what's my next step? After I factor it, now what? Okay, so what are the x's? Good. So he took this, he set it equal to 0, and he did it in his head, he got 1/3. What's happening at those x values in this question? Why do we care about those? We just found x values, but what did we find?
And those tangent lines have slopes.
Very good. The slope of the tangent line at those x values would be parallel to this line, so that means that they have a slope of 6. So at 0 and at 1/3, we have a slope of 6. The question just wanted the x coordinates, so we're done. We don't have to go any further. So those are our two answers. Okay. Anything else? So your assignment was 1 through 15. Right? Yeah, 1 through 15. That okay, we don't even have any new notes. If you notice, we covered everything yesterday. So I'm going to give you your assignment and we're going to do a couple questions together. So your assignment is just 16 through the end, which takes you through 31. All right, it's 2.5b. You guys are doing 16 through 31. So it's out of, what would that be? 15, 30? No, 32, I think. Yeah, 32. It's got to be 32. Okay. All right. I want to do 3 questions together. So you can just start a new piece of paper. You could do them a little bit out of order. I think doing 16, so let's do 16 together first. Has some trig. Trig is fair game for your quiz as well, right? We know 4 derivatives. So a couple things you need to have memorized for your quiz. We need to know the derivative of sine. What is the derivative of sine? Cosine. What is the derivative of cosine? Yeah, don't need those parentheses. So that would be negative sine. Then we had two others. We've memorized the derivative of e to the x. What's the derivative of e to the x? E to the x. And the derivative of natural log of x? 1 over x. Okay, so make sure you know these, product rule and motion. Okay, now again, I recognize that you could use your notes. I always write the questions where even just if you have this, that's not going to be enough. You're not going to be able to pass the test if you choose to use notes that you're not supposed to be using. You really do have to, the questions are always in a way that you have to understand it more than just having your notes handy. So make sure you practice them on your own. Okay, in fact, if you guys remember last year, did anybody take an AP test last year with the craziness and the AP? Yeah, right. And what they did is they said, even in calculus, they said, sure, it's open note. It's like calculator allowed, where normally it's not calculator allowed. And they recognize that you could access those things, but the questions are always difficult enough that really using your notes isn't going to get you an A, right? It might help you get started, but it's not going to solve everything for you. So I don't feel too bad about it. All right, so they want us to find an equation of a line tangent to this function at x equals pi halves. Your quiz from last week, question 4, was the same type of problem. You were asked to find the equation of a line tangent at an x value. We always need 2 things to write the equation of a tangent line. What 2 things do you need? Of any line. Slope, good. How are we going to find slope? Very good. So we know we're going to have to find the derivative. What else do we need to have in order to find a tangent line? A point. Okay, so the point is going to have an x coordinate and a y coordinate. Let's go ahead and find the slope. Let's start by finding slope. So when we find h prime, what do you guys notice? What rule are we going to have to apply? 2x sin x. Product, you guys see this as a product rule? I see it as 2 separate functions. The first function is, the first function is 2x, that's a product, it's times sine x. So the second function is sine. Okay, product rule, I'm gonna write it out. Product rule is first times the derivative of the second plus the second times the derivative of the first. So h prime, Michael, can you write all of this out? What will I write for f?
2x.
Good. What about s prime?
Cosine.
Good. And what about s?
Plus sine of x.
Yes. Good. Perfect. Everybody all right to hear? Okay. If you're asked to find the slope, they'll always, for now, at least in the class, they're giving us an x value, so we can take that x value, plug it in, and that will give us the slope. So this comes back to more stuff that you have to have memorized. We just need to plug in pi halves. So if I plug in pi halves for x, I've got 2 times pi halves, cosine at pi halves, sine at pi halves, times 2. Well, this works out pretty nice. The 2's at least cancel. Cosine at pi halves. What is cosine at pi halves? You can think of the graph or the unit circle. 0. Everybody all right with that? Yeah. Hallie. Oh, a plus. Yes, thank you for stopping me. You guys see that? I stuck a plus in between. So cosine at pi halves is 0. 0 times pi is 0. So that first product is 0. What about sine at pi? 1. Good. How did you do that, Milo? Did you do it from the graph or unit circle? Okay, great. So pi halves would be up at 90 degrees, right? It has a y coordinate of 1. So that's 1. So it's 1 times 2. Well, 1 times 2 is 2. So far we have h prime at pi halves. That's equal to 2.
Wait, how do you the cosine part? You just cancel out the 0.
So the reason why, so I would do it as a graph. So here's the graph of cosine of x. And at pi halves is right there, and so it's 0. Or you could do unit circle and say pi halves is here, and cosine goes with x, and that point is 0, 1, so cosine is 0. And if you multiply by 0, anything times 0 is 0. What did we just find? Yes, Annie?
I was just wondering, why did we cancel out the
Good question. Okay, so these two, because it was 2 times pi halves, whereas over here, that 2 is not multiplying it. So technically, I should have kept parentheses, like it's really sin at pi halves, that quantity times 2. Most of the time, we probably would write the 2 in front to prevent us from making that mistake. So that was a good question. Okay, we have 2. What is 2? Very good. This is the slope of the tangent. That's great. That's one of the 2 things we need to find. What's the other thing we have to find? A point. Okay, so on our point, Joe, what is the x coordinate of our point? What do we already know about our point?
Right?
Yep, so how do you find the y coordinate?
Plug it into the equation.
Exactly, yep, so we just plug it into the original. So I'm going to do h at pi halves, which was 2 times x, and then sine at pi halves. What is sine at pi halves? We just did it. 1. So this piece is 1. These 2's can cancel out. So I have pi times 1. So I have pi. So that's the y coordinate. We have our point. We have our slope. Who can write the tangent line? Will, can you write the tangent line?
Yeah,
What would it be?
y equals 2, and then in parentheses, x minus pi halves plus pi.
Good. Everybody good with this? I want to point out one thing that I sometimes see and students end up missing points. This answer right here, this is correct. If you write this and you don't write y equals, it's no longer correct. That y equals has to be there. I know sometimes we think it's like not important. It is. That's what makes it a line. So make sure you always have y equals your tangent line. Okay. There are 2 others that I think are helpful to do, and it'll help get us ready for our quiz. I'm going to jump ahead to 30. This one will help us with our quiz. I want you guys to take a second, read this, kind of get familiar with this question, then we'll go through it together. Okay, this is a good review of motion. Okay, so first let's just talk about what's happening on this graph. Okay, so I highlighted that it's a velocity time graph. So the y-axis represents velocity, the x-axis represents time. I want to talk about some of the key points. So right here, that seems like something important is happening. What do you think is happening at that point? What is that point in terms of what they described as happening? Good, because it said the engine burns for 2 seconds. So imagine if the engine is burning for 2 seconds, this is a rocket that's being fired up. What happens once the engine stops burning? It starts slowing down. Is it still going up, Berkeley, or does it start to come down? Still going up. So even though this is negative, what is negative right here? After 2 seconds, something is negative. Acceleration, because it's the slope of velocity, right? So if I'm looking right here at like this section, right here, the slope is less than 0. The slope is negative, but the slope of velocity is acceleration. So as Berkeley said, it's slowing down. So yeah, for the first 2 seconds, it's going faster and faster. The rocket burns out and it begins to slow down because now it's just coasting up. Okay. Another point strikes me as being kind of important. What about this x-intercept?
It begins to fall.
Begins to fall. Why would you decide that?
Its velocity values are now negative.
Very good, right? So notice at like 8 seconds, the velocity is positive. A positive velocity means you're going up. After 8 seconds, let's say we look at 9 seconds. At 9 seconds, the velocity is negative. Remember our rule that I said it will change directions when velocity changes signs. Velocity changed from positive to negative. So at about 8.5 seconds is when it changed from going up to going down. Okay, so someone else, what about 10 seconds? So if you read this again, what's happening at 10 seconds? The parachute opens, right? So think about this rocket. So the rocket's going up, it's starting to fall. At 10 seconds, the parachute opens. What happens to the rocket when the parachute opens?
Slows down from falling.
Good, it slows down falling. It's still going down, right? It still has a negative velocity. So at 10 seconds, sure, the velocity is still negative, but it's less negative because it's falling more slowly, right? So the speed is decreasing, so it's falling less. Okay, now see if you can answer all of those questions. Those questions should now be pretty easy. So I'll let you see if you can answer those. And on your homework, again, you're welcome to do them out of order. So you can just do this as your next problem on your assignment. You don't have to like try to space it and guess where you would be.
If you just
Yeah.
look at the 2 points of where it is.
Sorry
like,
for
For A.
what
you
is
said
the rocket's greatest velocity? I don't know. What did you guys put? What is the rocket's greatest velocity? So it's not a when. It's not asking when it happens. It's a what. So it wants to know like your units will be feet per
So it's
second.
just gonna be 200.
Yep, yep. And then just make sure you include your unit. So yeah, 200 feet per second.
So when the rocket, so the parachute comes at the second dot, right? So in order to find the speed,
How is speed defined? Anybody remember what is speed equal to? Absolute value of velocity. So at 10 seconds, what is the velocity? Velocity to y-axis is velocity, right? The y-axis is the other side.
that also be 50.
So good. So the speed is velocity is negative 50 but the speed is positive. And I should say feet per second.
Yeah, that makes sense. I got an answer. Negative 50.
Okay, so let's compare answers. What did you guys get for B? It says estimate the velocity at 7 seconds. Cameron, what did you put for your estimate at 7 seconds?
So the volume is about 50, but then you would like 250, which is
Okay. You were finding, I think, the slope. Did you find estimate the slope of this line?
yeah, and then I do
Okay. What is the slope of this line though? If I take this line, so he's estimating the slope of this. Did anybody else do that? Estimate the slope of that line? So you took the distance, which you said was 200, so like 200 over 8-ish, something like that.
I didn't know it.
Okay, great, and that works. So what is that? Down 250. We went down 250, and you would have gone over 8 seconds. Now, if you think the negative 250, we went down 250. What are the units on that 250? And if this is open to anybody, what are the units on that 250 if we're saying we're going down? We went down 250 what? Feet per second. Because you measured the y-axis, and the y-axis is in feet per second. So this would be giving us feet per second. And then 8, as we go this way, that was in seconds. So what have you actually found? Acceleration. Because what you found is you found the slope of a velocity graph. And if you find the slope of velocity, that's the derivative of velocity, which is acceleration. So you've approximated the acceleration in 7 seconds. And that's not what this question is asking, but that's the most common mistake I see. So instead of that, the question wants us to find just the velocity. The y-axis is velocity.
So is this guessing method?
Yeah, so you're just estimating like
45?
what that y value is. Sure, 45 would be a reasonable estimate. And I think the question is really asked to see if you know the difference between velocity and acceleration, because most people, the most common mistake I would see is that somebody gives acceleration. So maybe 45. And I think the easiest way to keep yourself straight is always consider units. So that would make sense because the y-axis is in feet per second, and those are the units for velocity. Okay, was the rocket moving up or down at 7 seconds?
Oh,
Up. Why?
slowly, it's slowing down, but it's still going up.
Okay, let's talk about it in its least amount of writing or work justification that we can. Why is it moving up at 7 seconds? What's it? Velocity. So it's up because v of t is positive. Okay. Not only is it good because then we have to write less, but that's more clear than having to explain something else. We're connecting it to like the calculus part. Okay, on D, estimate the rocket's speed when the parachute is released. So Milo, what did you say that is? What's the speed?
I said,
Good, because the velocity at 10 seconds, the velocity was negative 50, speed is absolute value, so it would be 50 feet per second. Okay, estimate when the rocket started to fall. What did you guys come up with?
8:44.
Yeah, any of those would be good because they did say estimate, so something about 8.5 seconds would be good, anything around there. Okay, estimate when acceleration was the greatest. Think for a second, we want acceleration, but we have velocity. How is acceleration defined? Derivative of velocity. Pretty all right with that? We know acceleration is the derivative. But looking at a graph, that means derivative is slope, so that's the slope of velocity. So if they're asking when acceleration is the greatest, we are looking for when the velocity graph has the steepest slope. It would have to be a positive slope. Where does it have the steepest positive slope? Beginning, about what time? Okay, can we be more specific? Somewhere in between 0 and 2. Where does it look like the tangent line would be the steepest? What was that? Yeah, well, 1 to 2, can we shrink it down like just at 1 point? Yeah.
Doing 1.8.
Yeah, just right before 2 seconds, right? So I would say like just before 2 seconds, that tangent line is the steepest. Its speed is increasing. If you imagine the burner, you know, it's burning and it's going faster and faster and it's going its fastest, it's accelerating the fastest just before 2 seconds. So I would say about 2 seconds, or I'll say just before 2 seconds. Or you could say, like Sean did, 1.8 seconds. Okay, so then the last question, when was the acceleration constant? Again, when you see acceleration, think acceleration is the slope of velocity. So when is the slope of velocity constant? Yeah, Ethan.
from 2 to 10.
Exactly, from 2 to 10. So this takes us back to what Cameron already found for us. So the slope of velocity, the acceleration there is constant from 2 to 10 seconds. Sorry, 2 to 10 seconds. Then the second part says estimate the value. Well, we already did that, right? We said we went down 250. We went over, what was it, 80? No, yeah, 80. And that was feet per second per second. You don't have to reduce, you can just leave it like that. and include your units. Yeah, Sean?
Would you need absolute value words?
No, when do we use absolute value? Who said it? Speed, good, only for speed. Yeah. Okay, I just want to see one of these last two and then I'll just let you guys work. But these two questions are super common. You'll have one of these, not tomorrow, but on your test. So like you might want to star this question. You're gonna have something very similar to this on your test for this unit. Your test is going to fall next Friday. So your test is next Friday. Okay, the reason that these questions come up a lot is because they like to see if you have the rules memorized where you can't avoid product rule or quotient rule. What rule are they asking you to apply on part A? What do you guys think? What rule are we asked to apply? Product rule. So this question is like designed to see if you have product rule memorized. These are really, really common AP questions. Yes.
Will the product rule be on the quiz?
Yes, I promise you. Yep. Motion, product rule, quotient rule, and those derivatives that we wrote at the beginning, sine, cosine, E, and L. Okay, so product rule. This is the first, this is the second. So Ethan, can you write this out using product rule? What would I write? H prime would be equal to what?
So it's F times G.
Good. So first times the derivative of the second. So I like how you said just G prime. Good. And then plus what?
Plus G.
Good. Everybody all right with that? So if this was a free response on your test, it's going to be a free response. You're going to get points for writing that out because you're showing you no product rule. Now they just want us to evaluate it at 2. So we say, okay, H prime at 2. So everywhere there's an X, I'm replacing the X with a 2. Not bad. Okay, this is where the graph comes in. This is a graph of F here, and over here is G. How do we find F at 2? What is F evaluated at 2?
5.
You guys all right with that? I'd go to the F graph, I'd go to where X is 2, and it's just the Y value. So yeah, it has a Y value of 5. So this is 5. Okay, yeah, please stop me,
So you do that for every F.
No, each one we treat just a little different. So like if we look at the next one is G prime. So since it's G, we're gonna look at the G graph instead. It's still an X value of 2, but what does that prime mean? Derivative. So when we look at a graph, how do we find a derivative? Slope. So this in words, I'm thinking to myself, G prime at 2, that's saying it wants the slope of G at X equals 2. That's what G prime at 2 represents. So what is the slope of the G function at 2?
0.
0. So that piece is times 0. Versus the question G at 2. G at 2 is just saying, what is the value of the function G when X equals 2? So what is the value on G? 2. The slope is 0, but the Y value, G at 2, isn't the derivative anymore. It's just the value of the function, so that's 2. Okay, how about F prime? In words, what does that mean? Derivative. So this would be the derivative or the slope. So we want the slope of F at X equals 2. I want the slope at that point. How many did we rise? Let's see, we went from 1 to 7, right? So we rose 6. You guys stop me if I'm wrong. And we ran 3. So 6 over 3 is 2. Well, that's 0. 2 times 2, so our answer is 4. What rule are they testing you on B? Quotient. This one, because of that 2 on the bottom, I see a lot of mistakes there. So let's just do the setup and then you guys finish it off. Okay, so on this one, J prime, Quotient rule, I'll write it out, bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, Joe, do you think you can write this out? What will we put for in terms of F and G?
For the bottom, will be 2G of X.
Good,
Times F prime of X. I mean, yeah,
Yep.
prime of X.
Good.
Minus F of X.
good.
Times.
You guys agree? Is 2 the derivative of the bottom? Let me give you something else. What if I told you a function was like 7x cubed? What's the derivative of that?
41X.
Good, because the 7, the number in front doesn't go anywhere, but you still have to multiply by the derivative of the function, right?
Yeah.
So when we take the derivative of this piece, the 2 stays, but we still have to multiply by g,
Okay.
so it's 2g prime.
G prime.
Yeah, right, that's the place where I see mistakes. Okay, so it's 2g prime, and then it's all over the bottom, just go ahead and keep it in parentheses, squared. Okay, see if you can finish that one off. Just plug in 6 and then see if you can evaluate everything.